Hai, Assalamualaikum warahmatullahi wabarakatuh. Okey, bertemu kembali kita dalam chemistry bersama Madam Hatini. Pada hari ini, kita akan masuk kepada topik hydrocarbon iaitu bahagian kedua, alkene. So, in this topic, the objectives are A. Draw structures and name alkenes compound according to the IUPAC nomenclature for straight chain and branch alkene, okay, where the parent chain is equal or more than 10. Number 2, cyclic alkenes from carbon 3 until carbon 6. Simple dienes from carbon 4 until carbon 6. Okay, B, explain boiling points of isomeric alkenes. C, describe preparation of alkenes through dehydration of alcohols and dehydrohalogenation of haloalkanes. D, outline the mechanism for preparation of alkenes through dehydration of alcohols. E, justify the major product form using Zev's rule. And F, predict the major product of elimination reaction of alcohols and haloalkane. So now kita tengok kepada the introduction in alkenes. Okay, the general formula for alkene is CnH2n. CnH2n for open chain structure. Okay, while CnH2n minus 2 for cycloalkenes. Okay, for example, okay, I draw cyclobutene. So cyclobutene, 1, 2, 3, 4, 5, 6. Okay, dia punya bilangan hidrogen dia. There are 6 hydrogen atoms. So the formula is C4H6, which is CnH2n minus 2. Okay, alkenes, the functional group for alkene is carbon-carbon double bond. That means yang berfungsi adalah kawasan inilah. Okay, functional group dia. Okay, and alkene is unsaturated hydrocarbon. Okay, unsaturated dia adalah hydrocarbon yang tidak tepu. So, more reactive than alkene. Alkene dia carbon-carbon single bond. Tapi alkene carbon-carbon double bond adalah unsaturated hydrocarbon. So, because of they are very reactive, so alkenes will undergo electrophilic addition reactions. Okay, so this is the type of reaction in alkene. So, kebanyakan tindak balasnya adalah electrophilic addition reactions. Okay, each carbon atom in carbon-carbon double bond is sp2 hybridized. Apa dia sp2 hybridized? sp2 hybridized which is dia ada 3 sigma bond. Okay, 3 sigma bond. So, 1, 2, 3 sigma bond and 1 pi bond. So, because of there are 3 electron domains, so the type of hybridization is sp2. So, which is the shape is trigonal planar lah, kalau sp2. Okay, so the restricted rotation of carbon-carbon double bond causes cis-trans isomer. So, kita dah berkenalan dengan cis-trans isomer dalam topik Introduction to Organic Chemistry. And alkenes are isomeric with cycloalkene. So, if you look at the general formula for alkene CnH2n, so this general formula also the general formula for cycloalkene. That means kalau kita boleh lukis alkene, kita juga boleh lukis cycloalkene because alkene ni dia isomeric, berisomer dengan cycloalkene. Okay, next. We look at the IUPAC nomenclature for alkene. So, alkene, the IUPAC names end with in. E-N-E suffix. So, start with 2 carbon, ethene, propene. Okay, tapi bila dah jadi 4 carbon, we need to numbering the position of the carbon-carbon double bond. So, kalau macam dalam case ni, the position of carbon-carbon double bond is at carbon number 1. So, that's why nama dia jadi 1-butene. So, if you change the position of the carbon-carbon double bond here. So, the name is 2-butene. So, kalau macam ini 2-butene. Kenapa 2-butene? Because of the carbon-carbon double bond at carbon number 2. Tapi kalau yang ini, carbon-carbon double bond start at carbon number 1. So, 1-butene. So, 1-butene and 2-butene will become the positional isomer. Jadi, kalau you lihat di sini, start daripada 4 carbon, kita perlu numberkan kedudukan carbon-carbon double bond. Okay, look at the example 1. Okay, so how to name the alkene structure? Okay, so first select the longest continuous carbon chain that contains the double bond as the parent chain. Okay, so macam yang kita dah belajar masa topik alkene, tapi kali ni bila kita nampak dia adalah carbon-carbon double bond, maka carbon-carbon double bond akan termasuk dalam dia punya parent chain. Because the priority antara alkene dan alkene, so alkene is more priority than alkene. So that's why bila kita nak pilih longest continuous carbon chain, dia mesti include carbon-carbon double bond. So kalau yang di highlight warna kuning ni merupakan parent chain. So how many carbon? So 1, 2, 3, 4, 5 carbon. So dia akan jadi pentene. Okay, so bila kita dah tahu dia adalah pentene, now if you want to number the parent chain, so numbering the parent chain from the end nearer. From the end nearer to the double bond, so that carbon-carbon double bond has the lowest number. So here, okay, we start counting the carbon, start from here lah. 1, 2, 3, 4, 5. So the position of the carbon-carbon double bond is at carbon number 1. So the name is 1-pentene. Tapi kalau kamu tersilap label, okay, nanti dia punya position dia akan jadi lebih besar lah macam yang ni. Dia akan jadi 1, 2, 3, 4. So dia akan jadi 4-pentene. So kita tak nak yang ni. Okay, this is the wrong answer. Now, indicate the location of the, okay, kalau dia ada substituent, okay, substituent, indicate the location of the substituents group to give it the lowest possible number. Okay, sama juga macam ni. Yang ni, sebabkan dia ada substituent, so substituent dia 2 carbon, so which is ethyl. Dari mana datangnya ethyl? Ethyl datang daripada ethane. Tapi bila dia jadi substituent, ane change to il. So, dia akan jadi ethyl. Now, the position of the ethyl group at carbon number 2. So, the name for this structure is 2-ethyl 1-pentene. Okay, look at example number 2. Okay, example number 2. So, first, we choose the longest continuous carbon chain. So, here 1, 2, 3, 4, 5, and 6. Okay, there are 6 carbon. 1, 2, 3, 4, 5, 6. Okay, 6 carbon. And then, the position of carbon-carbon double bond is at carbon number 2. Okay, so this is not 2-pentene, tapi dia adalah hexene. Now, the position of the substituent is at carbon number 3 and carbon number 5. So, the name is 3,5-dimethyl. Okay, ni bukan pentene. So, ada kesalahan di sini. So, the answer is 3,5-dimethyl 2-hexene. Kenapa dia hexene? Because of the other 6 carbon. The longest continuous carbon chain adalah 6 carbon. So, hexene. Why 2? 2 is the position of the carbon-carbon double bond. Okay, when the alkene has more than one carbon-carbon double bond, ene is changed to diene. If there are 3 carbons, we change to triene. Okay, example. Okay, tulisan ni dia macam bertindih, so kita lukis lain lah. So, 1, 2, 3, 4, butene. Okay, boot ada 4 carbon. And then the position of carbon double bond is here and here. That means there are 2 carbon-carbon double bond. So if there are 2 carbon-carbon double bond, we start counting here. So 1, 2, 3, 4. So the position of carbon-carbon double bond is at carbon number 1 and carbon number 3. So the name for this structure is 1,3-butadiene. Why di? Because of there are 2 carbon-carbon double bond. Okay, next is if there are 3 carbons. Okay, so kita lukis lain lah. So dia bertindih di sini. So 1, 2, 3, 4, 5, 6, and 7. Now the position of carbon-carbon double bond is at carbon number 1. It's at carbon number 4. Okay, 1, 2, 3, 4. And then 1, 2, 3, 4. Actually, this is not 1, 4, 5 heptatriene, but this is 1. Okay, I start counting here. Kalau macam ni, kita bilang sini lah. 1, 2, 3, 4, 5, 6, and 7. Okay, saya ubah lah. Saya ubah structure ni. Kita ubah structure Okay, now there are 6 carbon, which is there are 3 carbon-carbon double bond. So now the position of carbon-carbon double bond is at carbon number 1, carbon number 3, and carbon number 6. Okay, so if there are 3 carbon-carbon double bond, so the name is heptatriene. Okay, so 1, 3, 6, heptatriene. Why heptatriene? Tri means 3. There are 3 carbon-carbon double bond. Okay, next, the substituent with the carbon-carbon double bond, or we call alkenyl group, common name are used. Okay, example, okay, jika yang ni dia punya parent chain, kita kata dia punya parent chain, and then dia ada double bond, and then dia ada CH2. So yang ni nanti dia akan jadi substituent. So bila dia jadi substituent, namanya adalah methylene. Okay, methylene. Okay, here sample. Okay, katalah macam ni, and then dia ada yang ni, double bond yang ni. Okay, so yang ni akan jadi parent chain. So this one become the substituent. Tapi dia punya substituent dia 2 carbon. Now the carbon-carbon is carbon-carbon double bond. So bila carbon-carbon double bond macam ini, substituent ini kita panggil sebagai vinyl. Okay, kita ada methylene, kita ada vinyl, and then kita ada allyl. Allyl ni, okay, dia adalah tambahan kepada yang atas. So the formula is CH2, CH, double bond, CH2. Okay, this one we call allyl. So methylene, vinyl, allyl. Okay, next we go to the IUPAC nomenclature in cycloalkenes. So in cycloalkene, the carbon atoms of the ring double bond are numbered 1 and 2 in the direction that gives the substituent encountered first the smaller number. That means, kalau dia ada carbon-carbon double bond, memang kita akan bilang dia sebagai carbon 1 dan 2 pada carbon-carbon double bond itu. So here, if you start counting here 1, 2, and 3, so the position of the substituent group, which is methyl, is at carbon number 3. So the name is 3-methyl-cyclopentene. Okay, 3-methyl-cyclopentene. Okay, here, okay, if you start counting here, 1, 2, 3, 4, 5, and 6. So the name for this structure is, okay, this is ethyl, methyl. So E dengan M, which one come first? For sure E, right? Okay, so kita akan sebut E dulu. Jadi nama dia akan jadi 5-ethyl, 3-methyl, cyclohexene. Okay, 5-ethyl, 3-methyl, cyclohexene. Bukan terbalik sebab yang ni kena follow alphabet. Okay, E dulu baru kita tulis M. Okay, sebab apa? Sebab kita ikut alphabet. Okay. Now we go to the next part is for stereoisomeric alkenes with the prefix 6 and trans are used to distinguish the two isomers. Okay, so this one pun kita dah belajar secara detail in topic Introduction to Organic Chemistry. So this is a cis structure. So cis structure at least dia ada sepasang yang macam ni yang sama. But trans, dia bersilang macam ni. Okay. So, bila kita nak beri nama dia macam ni, kita akan tulis cis-2-pentene, trans-2-pentene, cis-1,2-dichloroethene. So, kena tahulah macam mana nak menamakan cis dan juga trans. Now, we look at the physical properties of alkenes. Okay, alkenes of carbon 1 until carbon 4 are gases, means methane, ethane, propane, and butane are gases. So start from carbon number 5 until carbon number 14, the hydrocarbon exists as a liquid. But if more than 15 carbon, okay, it will become solid. Now the boiling point of alkenes increase mostly with molecular weight. Okay, so the higher the molecular size or the contact surface area, okay, so the stronger the van der Waals forces. Okay, the stronger the van der Waals forces. So cis have higher boiling point compared to trans isomers because, okay, kita tengok dia punya structure dia. Okay, structure bagi cis. Okay, cis dia atas bawah. Okay, macam ni lah saya buat H. Okay, C ni besar sikit kenapa? Because C dia punya valence electron dia lebih tinggi lah. Okay, this is cis isomer. Okay, this is trans isomer. Lebih kurang macam tu lah. Dia punya yang saya buat ni adalah dia punya distribution of electron. So, cis-alkene is less stable than trans isomers because the electron repulsion between alkyl group on the same side of the double bond, which is steric effect. Jadi, sebab dia sama kan? So, bila dia sama, kekuatan dia sama kuat. Jadi, kat sini kita dapati bahawa dia berlaku repulsion, saling tolak-menolak. Okay, so belah ni tolak, kekuatan tolakan dia sama, so it will become the greater steric repulsion. Compared to trans because of dia tadi dia bentuk silang, so bila dia bentuk silang, jadi yang bahagian atas tu ada chlorine and hydrogen. Jadi dia punya steric repulsion tu can be reduced lah, akan berkurang. Okay. Okay, so untuk itu sahaja untuk bahagian naming dan juga physical properties of alkene. Thank you.